In this video, we're going to look at finding the area of some quadrilaterals we didn't look at in the last video. In the last video, we looked at what area was, how to convert units of area, and we calculated the area of squares, rectangles, and triangles. Please watch that video if you need to revise some of those topics. Specifically in this video, we're going to look at calculating the area of parallelograms, trapeziums, rhombuses, and kites. First, let's have a look at finding the area of a parallelogram. A parallelogram is a flat shape with opposite sides parallel and equal in length. Sides with the same number of arrow markings are parallel. In this example, the top and the bottom are marked with a double arrow, and therefore parallel. The left and the right side are marked with a single arrow, and therefore they're parallel. The formula for the area of a parallelogram is given by the base times the perpendicular height. The formula for the area of rectangles and triangles can be used to develop the area of other quadrilaterals. Using only what we know about rectangles and triangles, we might be able to find the area of these shapes by cutting them up and rearranging them into pieces. If we cut this parallelogram along that dotted line, and we remove that piece and stick it back on the left-hand side, you'll notice that it looks something like a rectangle. And if we multiplied the base times the height, we would get the area. And that's where the area of a parallelogram comes from. Let's have a look at an example. Here we have a parallelogram with a base 25 centimeters and a perpendicular height of 20 centimeters. We rewrite the formula with our known values and we evaluate. In this case, the area is 500 centimeters squared. Now let's have a look at a trapezium. A trapezium is a flat shape with four straight sides, has a pair of opposite sides parallel, identified with arrow markings. In this case, that's A on the top and B on the bottom, identified with a single arrow. The formula for the area of a trapezium is given by half times A plus B times the height, where A and B are the lengths of the parallel sides and H is the perpendicular height, or the distance between the two sides. You may see this formula written slightly different from time to time. Sometimes it's written with A plus B over 2, like a fraction. It doesn't change the formula, it still means the same thing. Again, using only what we know about rectangles and triangles, we might be able to find the area of these shapes by cutting them up and rearranging them. If we cut the trapezium along that dotted line, and we flip the piece and stuck it on the other side, again, it'd look like a rectangle. If we hadn't halved it in the formula, or halved the area in the formula, we'd end up with double the area of the rectangle, and that's why we have to halve it. Let's look at an example. In this example, the trapezium has a top of 200 centimeters, a bottom side of 100 centimeters, and a perpendicular height of 1.5 meters. You'll notice that the measurements are in different units. We've got to convert them. We'll convert the centimeters to meters because it's nice and easy. So we divide both the top and the bottom by 100 to get the meters. So the top will be 2 meters and the bottom will be 1 meter. Then we rewrite our formula with our known values and we start to evaluate. So we get a half times 3 times 1.5, and we get 1.5 times 1.5, and the area of the trapezium is going to be 2.25 meters squared. Let's look at the area of a rhombus. A rhombus is a flat shape with 4 equal straight sides. It looks a bit like a diamond. The opposite sides are parallel, and the opposite angles are equal. The area for a rhombus is given by half x times y, where x and y are the diagonals from corner to corner. Again, using only what we know about rectangles and triangles, we might be able to cut up this rhombus and stick it back together to form what looks like a rectangle. If we didn't halve x times y, we would end up with double the area of the rhombus because we were timesing by x, which is double the length of the rectangle when it's rearranged. Let's look at an example. So we have a rhombus with diagonals 200 centimeters and 100 centimeters. We rewrite the formula with our values and we calculate the area. In this case, it's 10,000 centimeters squared. Finally, let's look at finding the area of a kite. A kite is a flat shape with straight sides. It has 2 pairs of equal length sides that are adjacent to each other. The diagonals cross at right angles. So again, the formula is similar to that of a rhombus. We've got the area is half x times y, where x and y are the diagonals from corner to corner. Again, using only what we know about rectangles and triangles, we'd be able to cut this kite up and reform it as a rectangle. And that's where the formula for the area of a kite comes from. Now we have an example where the diagonals of the kite are 25 meters and 10 meters respectively. We place them into our formula and we evaluate, and we find the area of the kite is 125 meters squared. And that's it for this video. In the upcoming videos, we're going to look at areas of circles, sectors, and ellipses. We'll look at the area of composite shapes and then the area of irregular shapes. And we'll also look at volume and capacity. Thank you.